Welcome back. Now going to do a bit of a review of everything we've learned so far about maybe even trigonometry and trig identities, and then we'll see if we can come up with maybe use what we already know to come up with a couple more trig identities. So we know that from SOHCAHTOA we know that sine of theta is equal to the opposite over the hypotenuse, right? Like if we were to, let me draw a triangle here. If I were to draw a triangle here. Whoops, how come oh, there you go. Look at that. Okay, so if this is theta, this is the opposite, this is the adjacent, this is hypotenuse, right? Then sine of theta is equal to opposite over hypotenuse. Cosine of theta, this is basic review, hopefully at this point, is the adjacent over the hypotenuse. The tangent of theta is equal to the opposite over the adjacent, which is also equal to the sine of theta over the cosine of theta, and we showed this in a couple of videos ago. And then these are kind of almost definitional, but the cosecant of theta is equal to the hypotenuse over the opposite, which is the same thing as 1 over sine of theta. And you can just memorize this. I mean, I kind of find it silly that there is such a thing as cosecant. I guess it's just for convenience because, everyone knows it's just 1 over sine of theta. And same thing for secant. Secant theta. It's really for convenience. Instead of having to say, in the case of secant, oh, that's 1, if you end up with the equation 1 over cosine of theta, you can say, oh, that's just the secant of theta. I think it actually has some obvious properties if you were to draw a unit circle and all of that too. But anyway, so that's equal to the hypotenuse over the adjacent, which is equal to 1 over cosine of theta. And then, of course, cotangent of theta is equal to the adjacent over the opposite, which is equal to 1 over tan theta. And of course, that's also equal to cosine of theta over sine theta, right? It's just the opposite of the tangent of theta, right? Or that's the same thing as what? That's the same thing as the secant. No. It's the same thing as the cosecant of. No. Let me make sure I get this right. It's the same thing as the. I just want to get the inverses. Well, let's prove it what it is. Actually, I always confuse myself. So this is the same thing as 1 over the secant of theta over 1 over the cosecant of theta, right? Secant of theta, cosecant theta. And then that equals what? That equals the cosecant of theta over the secant of theta. I wouldn't waste your time memorizing. So we know that the cotangent of theta is equal to 1 over tangent theta is equal to the cosine over the sine, and it also equals the cosecant over the secant. And I wouldn't worry about really memorizing this. You could derive it if you had to. As you could tell, I really didn't have this memorized either. And we also learned in previous videos that the sine squared theta plus the cosine squared of theta is equal to 1. That just comes from the Pythagorean theorem. And then if you play around with this a little bit, you'd also get that the tangent squared theta plus 1 is equal to the secant squared theta. You actually go from here to here if you just divide both sides of this equation by cosine squared. So we know that. And then if you've watched the last 2 proof videos I made, we also know that the sine of, let's say, a plus b is equal to the sine of a times the cosine of b plus. Let me erase some of this because I don't think that is an important trig identity. You can derive it on your own. I just wanted to show you that you could figure it out. I'm using too much space. Okay, now I have space. Let me find that blue color I was using and make sure my pen is small. Okay, so that's the sine of a times the cosine of b plus the sine of b times the cosine of a. And you might want to just memorize it. This actually becomes really useful when you actually start doing calculus, because you have to solve derivatives and integrals that you might have to know the identity. And it's not that hard to memorize, right? It's the sine of one of them times the cosine of one of them plus the other way around. That's all this is. And then we also learned that the cosine of a plus b, it's the cosine of both of them minus the sine of both of them. So that is equal to the cosine of a times the cosine of b, and I proved this in another video, hopefully to your satisfaction, minus the sine of a times the sine of b. Now these are pretty useful, because from these we can come up with a bunch of other trig identities. For example, what is the sine of 2a? The sine of 2a. Well, that's just the same thing as the sine of a plus a. Sine of a plus a. And if we use this trig identity up here, that is equal to sine of a cosine of a plus the sine of a cosine of a, right? I just used this sine of a plus b identity up here, and well, a and b are both a. And what does this equal? Well, this is two terms that are just both sine of a cosine of a. So that just equals 2 sine of a cosine of a. So we now have derived another trigonometric identity that might be in the inside cover of your trig, or actually your calculus book. So let me all of these actually, if I could draw a square around all of them. But let's do another one. Let's figure out. It's actually once you have a bit of a library of trig identities, you can really just keep playing around and seeing what else you can. And I encourage you to do so. And you'd be amazed how many other trig identities you can come up with. For example, let's do cosine of 2a. Cosine of 2a is equal to cosine of a plus a. Right? And cosine of a plus a, what did we say? It's the cosine of both of the terms times each other minus the sine of both of the terms. So that equals cosine of a, right? Cosine of a times cosine of a minus sine of a, sine of a. We saw this identity was the cosine of a plus b identity minus sine of a. So what is this? This is equal to cosine squared a minus sine squared a. Well, that's interesting. I mean, I don't know, we could play around. This is interesting, right? Because this is the form a squared minus b squared, right? So that's also the same thing as a plus b times a minus b. So that's the same thing as cosine of a plus sine of a times cosine of a minus sine of a. I don't know. This isn't really a trig identity, but I'm just showing you could play with things. The cosine of 2a is equal to cosine of a plus sine of a times cosine of a minus sine of a. So the sum of the cosine and sine of a, and then times the difference. That's just interesting. I'm just showing you that what's fun about trigonometry is you can kind of keep playing around with it. And actually, that is how all of the trig identities were discovered. So let's say that we have, we want to figure out what cosine of, let's say, negative a is. Well, let me draw a right triangle. Whoops, that's almost a right triangle. And let's say this angle is a, right? So negative a, if we unit circle, would look something like this, right? Negative a. So cosine of a, if we say that this side is the adjacent side, this is a hypotenuse, this would still be the hypotenuse, right? And this is the opposite, this is the negative opposite. So cosine of minus a is equal to what? This is minus a, so it's the adjacent over the hypotenuse. So it equals the adjacent over the hypotenuse, which we just say is h. But that's the same thing as cosine of a, right? Because cosine of a is also the adjacent over the hypotenuse, adjacent over hypotenuse. Oh, I'm almost out of time. Let me switch to a new video.